is number 1 on the 4D packet. This is Brian Newton and the bag of coal that he ran a marathon with because he's clinically insane. So, we have this bag of coal. What we would like to know is the mass of the bag of coal. Okay, he drags it with a horizontal force of 130 newtons. The bag has a net acceleration of 1.00 meters per second squared. And we're given the coefficient of friction between the bag and the pavement. So, let's first do some sum of forces. Get some.
But can I really quickly write this picture down?
You can write whatever you want. I'm going to keep moving.
But
Sum of forces on the y. Fg minus Fn. And it's 0 because this thing is not rising into the air, nor is it sinking into the pavement. Fg is equal to Fn. Fg is equal to mass times gravity. That seems like it might come in handy, doesn't it? It's got mass in there. We know gravity. And we've got something that will relate us to normal force. Okay, wunderbar. So, now let's look at the x-axis. Sum of forces x. Force applied minus force of kinetic friction is equal to mass times net acceleration. Here's one of the problems that you don't like so much, young Malcolm. So, we're given this. We have something that will relate us back to this. So let's go ahead and, actually no, you know what? We can use this as it stands because we have mu k is equal to Fk over Fn. So we can create an expression for Fk, mu k Fn equals Fk. All right, so now we have force applied minus quantity mu k times Fn equals mass times net acceleration. We have an expression for Fn okay, now this is where you want to freak out a little bit and go, but there's mass on both sides, right? You can do some algebra magic here.
Well, but you could just move you could just divide the acceleration over there and it wouldn't make...
Yes. Bless his little heart.
Okay. I'll give it a skip.
This is the point at which most people freak out. If you didn't freak out on that point, then yay! You get a not freaking out star on your forehead.
Wait, why are we freaking out?
I don't know. It's not that difficult, but it's the classic point where lots of people do go, I can't solve for math. There's math on both sides. Okay, no, I'm hoping nobody does. But you're solving for mass, so, there are a bunch of different things you can do algebraically here to isolate mass.
You're trying to solve for math.
I'm trying to solve for mass. So, does anybody need me to go further with the algebra?
Probably.
Yeah, do it.
Okay. If we divide this whole side by mass, getting rid of that. Is that what I did?
You can't do that.
Oh yeah, you can actually. This is actually what I did. It's around the barn door. Just relax.
Oh, I get it.
Wait, there's some travel.
Yeah, you can.
Then I have F applied divided by mass minus mu k g equals a net, and then I just I basically took this over here and added it. So then I can just flip it, and what we end up with is F applied divided by a net plus mu kg equals m.
See, I understand that.
Okay.
Oh, because you move that over, you add it, and then you just remove the FA from add.
I did a little shortcut there.
Okay.
Yeah, what'd you do?
Whatever equals.
Okay,
Do you need me to walk back through the algebra?
I think I.
Yeah, question. Why is F applied on top?
Yeah, that's what I was just wondering.
That flashed me on the bottom.
No.
Because if you flip it over, if you
No.
if you divide it on the other side, it's going to be on the bottom, but then you have a reciprocal, so you flip it.
No. What?
Reciprocation.
Because the mass is on
That's
why.
that's the most common algebra mistake there is, solving for reciprocal.
Understood.
I didn't have to do that, but I came out with like the same.
And there are 3 different ways to get the same equation in the end. So if you got 51 kilogram, or my raw answer was 50.9807 kilograms, then it doesn't matter how you got there algebraically. Okay, you good with that? Oh, my little Fruit Loops and Panic Bunnies.
Okay.